The materials I'll be using for this lab are graduated cylinders, cuvettes, test tubes, spectrophotometer, distilled water, a pipette, and Red 40, which can be found in many sports drinks like Gatorade. Okay, first we need to make 6 dilutions of our 17.8 millimole solution of Red 40. We're going to do this by using figure 6 as a model. Alright, so I finished preparing our dilutions from our stock solution, which was 17.8 millimole of Red 40. So I basically had 8 cuvettes. The first one was a 10 milliliter solution, which was our pure stock, which is basically our control. Then we have increments that we go down by. We have 8, 6, 4, 3, 2, and 1. We also have a blank cuvette, which can be used to calibrate the spectrophotometer. After the spectrophotometer is finished warming up, you want to put a blank cuvette in there to calibrate the system. After calibrating your spectrophotometer, I used the 8 milliliter stock solution and 2 milliliter distilled water solution and placed it in my cuvette using my pipette. And I placed it in the SpectroViz and clicked run. While your SpectroViz is running, it's going to take a while and it's going to make a graph like this. What you're going to do is use your stylus to select the highest peak of your graph. Selecting the highest peak of the graph is basically selecting the highest absorbance value, which is the optimal absorbance value for your cuvette. Okay, so we just got the absorbance value of our 8 milliliter stock solution and 2 milliliter of water. This absorbance value was 0.209. Now we want to calculate the concentration value of our solution. We're going to do this by using the formula M1 times V1 equals M2 times V2. We're going to do some algebra and rearrange the equation so that we get M2 as a product. Our M1 value is going to be 17.8 millimoles. And our V1 value is going to be 8 milliliters, since that is how much stock we use. And our V2 is going to be 10 milliliters because that's the total amount of milliliters in each test tube. Doing the calculation, we get a value of 14.2 millimoles. Alright, so now that we have finished calculating all our concentrations and recording all our absorbance values, we have the challenge of trying to find out the concentration of our unknown solution. My unknown solution, which I use, is red Gatorade, which you can buy in any store, convenience store. So what you want to do is fill up a cuvette with this solution and place it in the spectrophotometer. Now that we have calculated the absorbance of our unknown solution using our spectrophotometer, we want to calculate the concentration of the unknown. We're going to do this by making a graph of the absorbance versus the concentration. And when we make this graph, we're going to have a plot, and then we're going to make a trend line. And we're going to plot the absorbance of our unknown along the trend line to estimate the concentration of our unknown. So this is our absorbance versus concentration graph, where we have absorbance on the y-axis and concentration in millimoles on the x-axis. We have our points that correspond with the concentration and absorbance values. We have a trend line, which can be used to estimate our unknown solution concentration. So we go along the trend line to estimate the absorbance of the unknown, which is 0.257. Once we estimate that mark, we go straight down to the x-axis, which is the concentration, and we estimate the concentration that corresponds with our estimated absorbance. I estimated a value of 15.6, and this is an estimation. It may not be correct and say,